start with superposition. Okay, in our last class, you already got some concept that what actually we are going to discuss in this chapter, right? We are going to
Yeah.
discuss about two or more than two waves when they are going to combine and when they are going to like in different directions, moving towards each other or moving from each other, like different cases we need to discuss today. So our first concept is related to principle of superposition. So first thing that we are going to discuss about superposition is the principle, that actually what is the principle related to superposition. Then we will continue with the other terms too. So the principle of superposition is when two or more waves, when two or more than two waves, one important thing with the same frequency, right? Because we are not going to discuss about frequency right now. Our main focus is on superposition, right? So that's why we keep the frequency constant. It's scattered in this concept also that we need to cover frequency also, right? So that's why we keep frequency constant, because solving two or three concept at a time, that was a very difficult task. So that we solve and we study only one concept at one time. That's why we keep other quantities constant, right?
Is the wavelength also kept the same?
Wavelength, if you talk about the wavelength, so basically frequency wavelength both are like inversely, right? You already studied in Doppler effect in space physics, and you already know that if we increase the frequency, wavelength will decrease, and if we increase the wavelength, frequency will decrease, right? So if we keep frequency constant, so wavelength will also be constant, right?
Okay.
Because number of time per unit time, number of waves per unit time remains same, it means that the length of waves will also constant, right? So that will make easy for us to understand the property of superposition. Once we got the concept of superposition, then we will study about frequency and wavelength too.
Yeah, I was asking this because I was when I was solving the past papers, I saw like the marking scheme for one of the papers, and
Yes.
the question was state three conditions that must be satisfied in order that two waves may interfere, so the superposition. And then the answer was that they have the same wavelength, same amplitude, and like constant phase angle difference.
Yes. We also discuss all the terms in detail, because this is our first topic and this is our first impression of this chapter. So that's why we are first to start with only constant frequency, right? Then after that we have different laws and different scenarios in which we calculate wavelength and frequency. There is also a concept of first order, second order, because we are going to study standing waves also, right?
Yeah.
So this chapter is new one and all concepts are new for you. So we are going to discuss each and everything in this chapter. So displacement is the sum of displacement of each wave. Sum of displacement of each wave. Okay, statement is little bit lengthy, but the concept is very, the concept is, let's suppose if we are having two waves, so let's first draw two waves, then try to combine those waves. Let's suppose one wave is going to move towards right hand side, and the other one we are going to draw on this side too. Okay, so let's suppose in our first wave, or our first wave is moving like this form. This is the pattern, and this is the pattern of the second. Initial state we are only going to discuss about the pattern and the displacement, because in definition they mention that your resultant displacement is the sum of the displacement of each wave. So let's suppose if this height of the wave is equals to x, So this is also x, right? And if we combine these waves, so you know that both are going to combine and your final displacement is the sum of displacement of each wave. So what will be the representation of your final wave? The representation of your final wave will be like this. Now we need to combine these two waves, and after the combination, your final waves will be like this. Any idea how we are going to draw the final wave?
Oh no. Is it
Okay,
gonna be just the same? Because there's no difference.
okay. Let's suppose if we consider with the amplitude of first wave is x and second one is also x. If we add x and x, so what will be your final answer?
2x?
2x. So what we need to do, we need to increase the amplitude by 2x, right? So your wave will be greater in displacement like this, right? And we know that frequency and wavelength is constant, so we only increase the amplitude, and this value gives you the concept that this is 2x, and downward this is also minus 2x, right? So this is the concept of superposition, that if we combine two or more than two waves, so your final displacement will be greater than the initial one. Actually what we are doing over here, this is our first wave and we add up with the second wave. 1 plus 2 will give you the concept of this final wave. This is our resultant wave. Is it fine?
Yes.
So actually we need to add them in the with the reference of the amplitude. So that will give you a clear concept that how waves are going to be added. And by the graphical representation, you also understand that how waves are going to be added or how this amplitude is going to be increased. But there is also some other consequences with this problem or this superposition is you studied about the upper part of the wave and the lower part of the wave, right? Let's suppose in this particular example, crust is going to be added with the crust of second wave, because this is the crust of first wave and this is going to be added with the second one. This is the crust of first wave and this crust combines with the crust of second wave, right? And if we talk about the trough, the lower part of the wave, so the trough of this lower of this first wave is going to be combined with the trough of second wave, right? So actually what is the concept over here when going to same components of the wave, right? Like crust plus crust, trough plus trough. So your wavelength, or sorry, your final resultant wave will be the addition of individual wave, right? It means that if we combine the crust and crust of both wave, so this is x. So it means that your wavelength or your final resultant wave will be the addition of your individual waves, right? But let's suppose if two waves are like this, that crust of one waves combined with the trough of the other one, right? So what will happen next? So for that purpose, let's suppose another example. If we again draw two waves with different orientation, you got the concept of the same components of the wave or any confusion in that?
I'm a little confused when you started explaining the difference of the trough and stuff.
Okay. Okay, this is very simple. Let's suppose we are having two waves. According to the definition, we need to combine two or more waves, right? So initially we only discuss the overall effect, that how waves are going to be add over there, right? But specifically, if we talk about the components of wave, so let's suppose if the crust of one wave is going to be combined with the crust of second wave, right? So
Oh,
same components are going to be add, right? It
okay.
means that that will increase the final value. X plus x will increase the final value. Or
So both the troughs will be added and both the crusts will be added.
yes. And let's suppose if we consider the value of trough. So the value of trough will be minus x because it is opposite in direction, right? This
Yeah.
will also be minus x. So if we combine crust and crust, so crust
Yeah.
plus crust means x
Two
plus
crusts.
x, right? Because both are the upper part of the wave. So that
Yeah.
will make a greater wave as compared to the previous one. If we are going to combine crust plus trough or trough plus crust, so the addition will be different. That will be x plus minus x. And you know that plus minus will be minus, and your final resultant wave will be equal to what? Zero, right?
Okay.
Because we need to include the direction also, because the upper part and lower part of the wave is also an important part. So we need to
Yeah.
include that one also, right? Initially we only discuss general overview of the definition, then we specifically talk about crust and trough. So let's suppose if your second orientation of wave is different from the first one, so then you are going to have different results from the previous one. Let's suppose again we are having two waves, one on the upper side, second on the lower side, and we are going to draw our resultant wave in the middle. Actually, this is completely new concept for you. We didn't study this concept in our O levels or IGCSE, so that's why it might be difficult at initial stage. Let's suppose this is our first wave and this is our second wave, both having same frequency and wavelength. Don't worry about that because we already mentioned in the definition. So again, this is equals to x and this is equals to minus x, right? And this is
Okay.
equals to x and this is equals to minus x. Okay, now if we try to study about their combination, the combination will be like this. This is the lower part of the wave, and this lower part is going to be combined with the upper part, right?
Plus and minus will give you 0, and then the minus and plus will give you 0, so that you're gonna have like nothing then.
Simply. And same goes over here. This is the upper part of the wave that is going to be combined with the lower part of the wave. So it means that we are going to just draw a straight line on zero. It means no wave of final resultant axis, right?
Yep.
Because both are going to be add in opposite direction. So they both cancel out the effect of each another wave, right? So that is the concept.
Okay. I
And
get it. So it's adding and subtracting
yes, it's
two
just like
different.
adding and subtracting. And when
It's like in O levels when you had the uh, displacement on the object, so they'd have like 4 newtons on one side
yes,
and four
we
newtons
also
on the
discuss
other
in
side.
the reference of forces also. This is just like the addition of forces with the reference of direction, right?
Yep.
Okay, and there are two terms which are related with this concept, that crust plus crust or crust plus trough. If same components of waves are going to be added, so that is known as constructive interference, right?
So when how? Can you repeat that?
Actually, we need to use now term because that is very much lengthy to explain that crust plus crust combine and your final resultant will be this. So we
Yeah,
just
yeah, yeah.
a term a constructive wave. Constructive wave means that if same component, or let's suppose if crust of one wave combines with the crust of second, so that will give you a final resultant wave that is greater in displacement as compared to the individual. So that
So
concept is
constructive
known as
wave is
constructive
when
wave.
so
Yes.
constructive wave is when the same component of
Yes,
wave
same
is
components of waves are going to be added. So in short form, we are going to use constructive interference, right? Or just write it constructive interference. That will be more easy because it depends upon number of wave. Maybe there are more than two waves in our question. So it shows you that same components of wave, components by name of component, you know that we are talking about crust and trough, right?
Yep.
Both are same components combined with each other. So your resultant displacement or resultant wave has double the amplitude, right? That we already mentioned in our diagram. We already discussed this concept. Now we are getting the that we are going to, rather than writing detailed explanation after every diagram. So this is known as constructive interference. And if we talk about the second term, so second term is known as destructive interference, right?
Okay. Wait, I'm writing it down.
Okay, if you are not going to write during the class, so I will send you after the class also, or you may take the screenshot by yourself too, right? It's up to you.
Okay.
In during the class, try to make your own notes. Let's suppose if something you find important and we are not writing that on the board, so you may take that notes, because this whole PDF file I'm going to share after every class in the group, right? So don't
Yeah.
worry about this. So next one is destructive interference. And in destructive interference, you got the concept that is opposite to the constructive interference. In this component, we are going to combine the opposite components. When opposite components we combine, the resultant wave or zero amplitude, right? That's the concept of interference.
Okay. And also superposition can only happen if they have the same amplitude, or does the amplitude of the different.
It also happens with different amplitude, but I already mentioned that we are just talking about the initial concept, so that's why we are taking same magnitude for our simplicity, right? Otherwise it may be any. Let's suppose one is x and the second one is 1.5x, so we just combine 1.5 plus 1, so that will be 2.5. Okay, because once you got the concept, the numbers are just calculations, right? So any confusion in this concept?
No, it's clear, but if the amplitudes of the waves are different, right?
Yes.
If they're opposite components of waves are combined, so but if the
Yes,
amplitude
then you will
of
get
the
some
first
resultant
wave is
wave.
like, so
Yes.
if the amplitude of the first wave, so like it's a trough, for example, is like 4, but then the amplitude of the crest of the second wave is like 3, so then what's it gonna be?
So you are going to get 1x. It means 4 minus 3. You are going to get 1 over there, right? We are writing this constructive and destructive according to our same conditions, right? Because we mentioned that same frequency, same amplitude, right? So that is
Yeah.
related to that. But when we are going to solve questions, so now you already got the concept. If we combine different amplitude, so that is going to be included in our next topics also. So we are going to solve that too, right? So don't worry about that. Okay, your question is valid. Let's suppose I got your question that if, let's suppose, crust is 4 and trough is 3, or trough is 4, crust is 3, and both are going to be combined, so we just simply subtract. Because the important thing behind this concept is to get the concept of that when we are going to add the waves and when we are going to subtract their amplitude, right? So we got the concept when same components are combining, so we are just going to add the amplitude. And when different opposite components are going to combine, so we need to subtract them. So that is the concept behind this whole theory, right?
Yeah.
And one more important thing is that, let's suppose if they ask that is it possible to apply a law of superposition on transverse and longitudinal wave. So it is possible that we can easily apply a law of superposition on both transverse and longitudinal wave, right? It is not for transverse only, it is also for longitudinal, right?
Yeah.
So one important note is that this principle applies Because let's suppose if we have two speakers or two sound source and we just play same sound on both the speakers, so that will increase the amplitude of the sound, right? And we know that sound is the example of longitudinal wave. So this principle of superposition applies to all type of wave. And you know of wave, there are two types, one is longitudinal and second one is transverse, right?
Yeah.
Okay, so this is our first concept related to superposition, right? Okay, let's move toward the next one. Okay, next concept is related to standing waves, right? Because in previous section we discussed about waves, the traveling waves from one point to another point. But now we are going to talk about the stationary wave. Waves means now we are going to constrain and we are going to restrict their path. Let's suppose if we take example that one rope is tied at the one end, or it is going to be tied with a wall or the hook that is fixed in the wall, and the second end of that rope is in our hand, and we are going to vibrate that rope, right?
Yeah.
So what happens over there, that rope are now going to be connected at two fixed point A and B, and waves are not going to exceed point A or point B, or we can say that waves are not going to exceed that fixed point, right? So those waves are known as stationary waves because they can only vibrate in their limited area. They are not going to move like the water waves, right? Because water waves have no limit, they can move in any direction, as many distance they want they can easily cover, right? So those waves are progressive waves or traveling waves. But if we restrict them in a specific area, just like water in a tank, water in aquarium, so then waves are going to be generated. So those waves are known as stationary waves because their area is now limited and restricted. Okay,
Okay.
so now we are going to discuss about this stationary wave because many experiments in our daily life are connected with the stationary wave. Tomorrow, inshallah, I will show you the complete setup of a stationary wave, which is in our university. We also used to do that practical with university students in first year and second year of university. So I will definitely show you the concept of a stationary wave over there. So the
Okay.
next topic is stationary wave. Okay, you may also use the term of standing waves too, right? Stationary or standing wave, both are acceptable, and they also used to write both terms in the exams also. So
Okay.
basically, stationary or standing waves, because you know that first we need to write the definition, that is very much important for every question. Stationary or standing wave are produced by superposition of two waves. Because we are at initial stage, so we start with two waves because more than two waves is a typical task. So first we need to study with two waves, again of the same frequency, of the same frequency and amplitude, traveling in opposite direction, right? Now definition is almost same like the stationary, but only there is a difference of that in stationary waves we are going to talk about their addition of amplitude, but in this we are going to talk about their uh, interaction with each other when they are moving in opposite direction, right?
Yep.
So let's suppose if we take a very common example of our daily life like stretched spring. If we continue with the stretched spring or stretched strings, both are so let's suppose what we need to do that let's suppose we consider 2 points. One point is over here, that is point A, and we take point B over here, let's suppose. And let's suppose we consider string from point A to B. String is not very tightly fixed at both points. It is just a normal tie at both ends. So this is the string, right? So let's suppose if someone tried to pull this string and then just release. So what will happen with the string? If just someone plucks this string or just someone try to pull that string and then release. So what will be your observation with the string? Just like the guitar strings, if you take the example of guitar strings, so that strings are also fixed at both end, right? And when we try to strike those string or when we try to plug that string, so what will happen, they starts vibrating, right? So vibrations are going to be start over there. Is it right?
Yeah.
Okay, so actually our observation will be like this: either they are going to vibrate in the upper direction or either they are going to be, because there is vibration and vibration, you know that it is to and fro motion. So this string is going to vibrate in this form. So this is known as the concept of the standing waves, because waves are going to be produced in the limited area. The guitar is a very simple example. So waves are generating over there, but they are restricted between 2 points. So that's why they are used to say as stationary or standing waves, right? And what we need to study in this standing wave, we need to find out the wavelength, frequency, and all other different concepts from this standing wave. And let's suppose if we want to write some more statement related to it, so we can also write let's suppose how this or how these stationary or standing waves are going to be achieved. So actually they are going to be achieved like this concept can be achieved. I hope you got the concept that how standing waves or stationary waves are going to be produced, right?
Yes, I got it.
Yes. Because first of all, we need to know about the difference that if we are talking about 2 or 3 topics, so what are the different points related to those different concepts. Then we start talking about their individual factors, right? And one more thing, we know that wave is the disturbance of the particle when particles try to vibrate. So then wave is going to be generated over there. So between 2 points, what actually is going to be happen over there, that particle start vibrating, let's suppose from this point, and they are going to strike the other point. So what happens next? When this strikes from point A to point B, then it got reflect back, right? So due to that reflection, they start to vibrate for longer time, and after some time when their energy is completely converted into the other form, then they comes towards rest state, right? So actually the concept of reflection is mentioned over here, that this can be achieved by traveling wave and its reflection. So when this point, let's suppose if we consider this single point, when it tries to move towards point B, so it strikes point B, then he found that there is no other way to move forward, so it reflect back towards A. and due to this reflection we are getting the opposite amplitude or the opposite vibration in the particle, right? Let's suppose if we get upward motion in our initial stage, so we will get downward motion in our second stage, and this vibration is going to be happen in a very short time interval. So that's why we observe like a loop pattern between point A and B. Okay.
Okay.
Okay. Okay, now you observe that there are two different components in our stationary and standing wave. One is the fixed one, and second one is the open vibrating pattern, right? So there are two components, we can say that, or two factors. This part is known as the node. Now we are going to use the term node for the fixed point, and we use the term of antinode for this part, right?
Oh, I saw these in the past paper. They said these
Yes.
words.
So this is also an important term for you because sometimes they ask that define node or define antinodes. So basically the maxima of the wave shows you the antinode, right? Where your vibration is maximum. So this concepts give you the definition of the antinode, the maxima of the wave, and the
Okay.
minima of the wave, the minimum value, we can say that the minima. So minima of the waves gives you the concept of node, right?
Okay.
So basically, if you want to define them, so how you are going to define node and anti-node? Any idea?
So node is like the highest. It's the
Hmm?
it's the
Maximum,
amplitude.
maximum
It's a
amplitude, right?
maximum amplitude, and node is the minimum
Yes.
amplitude.
So we you can also write with the reference of the previous topic that where displacement is zero, so that point is known as the node, or where amplitude is zero, so that point is known as node, and where displacement is maximum or amplitude is maximum, so that point is known as anti,
Anti-node.
right? So it is a point where the amplitude or we can also the term placement because for the concept superposition, and this is we can say that a type of application of that concept of wave zero, right? Minimum. You may use any term that, and for the second term, because key terms are very much important, in different questions they use different types and different terms. So about, so that will make easy for us to understand the question. And the point where amplitude displacement of wave is maximum, so that point is known as antinode, right? So these are two concepts. One is related because for the time being we only consider one wave, right? And we know that it is not compulsory to have only one wave. There may be different type of wave, and I will also show you a experiment that is going to be practically happen in our labs also. I will share a link of that video also and try to show you in the class also. So that will give you the concept how these waves are going to be generated practically, right? Standing waves, because we
Okay.
need to study about number of waves, that how many waves are going to be generated, how many nodes, how many anti nodes are going to be formed in our experiment. So that is our important part, right?
Yep.
So any confusion in these two topics?
Um,
Okay.